Thank you so much for taking time to listen and view our product videos. At this point, I'd like to call on our session presenter this afternoon, Engineer Ace Bistar, to please take over. Ace, the floor is yours. Go ahead, Ace. Ace, hi. We cannot hear you. You are not unmute. There.
Hello?
Yes, yes. Better this time.
All right. Okay, sorry. Did you hear me earlier? No.
No, you can start from the very start of the agenda.
All right. Okay. So thank you everybody for attending this webinar, and we are excited. I am excited to present this webinar to you as we discuss about the Equip Smart Trip unit that we had for our MCCBs and our ACBs. Okay, so the agenda for today is we will tackle about the electrical challenges, and then from these electrical challenges, what are the market trends? Why digital? So why are we going to be digital? And then we will discuss about the Equip Trip unit technology coming from our ACBs, MCCBs, and what we call an Equip app, wherein we can upload.
Ace, there's no audio. Sorry, can you start again from slide 2? We cannot hear you. We cannot hear anything. Still no audio, Ace. Okay, please allow us a few more seconds as we try to address this technical glitch from our end. We do apologize for this one. However, as some of you have witnessed earlier on, we have made our technical rundown and everything was running smoothly. So let's just give a few more seconds to our session presenter to ensure that our audio experience is better. Ace, just feel free to say something so that we could also test anew the audio from our end and from yours. Okay, let's okay, Ace. I just resent the host button to you. Let me know if you can try it out and start from the top of your presentation.
Hello, can you hear me now?
Yes, better.
All right. right. Okay. So let me just share my screen. Okay. Okay. All right. So still okay?
Yes, go ahead, Ace. Thank you.
All right. So we do apologize for that, and welcome again for the for our webinar for today. And we will be discussing about the ABB Smart Trip Unit, wherein I am so excited to present this to you on what are the technologies that we have embedded in our products. Okay. So the agenda for today is that we will discuss about the electrical challenges, and then the market trends that we are in today, and why are we going to digital? Why is digitalization is important? And then we will discuss what is the chip chip unit technology. All right. Okay. So the challenges that we have are normally we have these abrupt power failures. So from these abrupt power failures without energy, so we get concerned on things that we had. So especially if we run out of power in our cell phones. And then for the electrical heat buildup, so sometimes our electrical system does create heat. So why understanding our system, why there is an electrical heat buildup in our low voltage switchgear. Next is this nuisance tripping. Have you experienced this nuisance tripping that most of the time you try to restart or reset the circuit breaker, but it trips again, thus flowing or just stopping any activities that we have in our plant. Okay. Next is the high energy cost. So aside from these kinds of problems, so we are also encountering high energy cost. And then with this one, we have those unwanted downtime, and then our operational expense budget. This also includes the maintenance budget. Sometimes when we do the budgeting, what we do is that we just assume that this amount of cost will be done for the whole year. But what is happening is that there are sometimes that we need to be there can be a reactive scenarios wherein there is a unwanted downtime and then we needed to replace, and this is outside of our budget. And then next is the aging equipment in our plant. So with the aging equipment in our plant, we cannot sometimes what we wanted is to retrofit this one or replace it with the new one. Or sometimes what we need to do is that aside from retrofitting, we create a new switchgear. So aging equipment is somehow a problem with the old electrical installations. And electrical reliability. So with this electrical reliability, most of the time what we had is we are dependent on the grid. But if the grid is unreliable, what we do is that we have this we put some generators, and then what we do is we go into an island mode so that we can continuously use our facility. And then on top of this one is that the integration. All right. So integration is also being a problem today. So it's not because there are multiple, it's not just because of the multiple brands that we are encountering and the multiple solution that is available, but it is also because of the communication that's being used in the plant. And then if you have some like a BMS, you have some SCADA system, so they do have some different protocols that we need to comply in order to expand and to use this system. All right. And with this, so what is important of all of this problem is that we need to understand. We need the data. We need the data in our electrical system to understand why we have these kinds of failure, why we do have some high energy costs, and we need to be informed. We need to be informed when will be the preventive maintenance, when will be our component will break down. So these are the things that are we need data and information with. All right. So as we go on with this problem, so we have the new trends. Okay. So with the new trends that we had today, so as we always hear, what is the Industry 4.0? So actually, Industry 4.0 is we can consider it as as simple as it's an internet technology. Okay. So why? Because with the internet technology that we had, everything can be connected and everything can be converted into things that a human being can understand. Even machines can now communicate to us whether they will be able to trip or they will be able to be maintained. So they can machines today, smart machines or smart component today has this kind of ability. Okay, and also aside from these trends in our electrical distribution or electrical system, so we also need to have this energy efficiency. All right. So as you can see here, this is very important to us as we wanted to limit the carbon emission. All right. So why? Because what we are seeing here is that at the year 2080, there is a possibility that if we do not reduce the carbon emission, then we will have an increase of our temperature of 3.2 to 5.4 degrees centigrade. So today we are actually experiencing this global or climate change that we had, and just recently we've been struck by this typhoon Ulysses. The rain is so heavy, the winds are strong, and even after the typhoon, we experience the sun. The sun's heat rays are actually very, very hot. So it actually hurts your skin. So these kinds of things is what we needed to reduce. All right. And in the global building infrastructure, so 40% of this one is the energy consumption, wherein it distributes of 36% of carbon emissions. So we need to lower this one. Right. And also, in the near future, so we had this yesterday of our power system. So we only have this energy sources like the generators, power plants, and renewable energy, and then it will go to the consumers. And today, what we are doing is that everything is integrated with this and today. And for tomorrow, there would be a lot of what we call a virtual power plant, or what we call a cluster of energy resources, because as more and more renewable energy like solar panels, wind turbines, and also the use of electric vehicles, so this can actually provide us an on-premise energy resource. So for tomorrow, everything will be integrated and everything will be digitalized and will be controlled. All right. And the resiliency when it comes to electrical energy, then it can be converted into a specific place or into a macro place. So this is something that we are looking at in the future. All right. And the evolution of this electrical distribution. So we have the microgrid concept. All right. So this microgrid concept is basically the system wherein a certain like example generator, renewable energy that you can sustain on a certain load, but it's not coming from the distribution side. So the improvement of microgrid system is actually something that we will be enjoying in the future, and which will be a trend in the future for electrical resiliency. And for the future factories, the future factories will be somehow very could be independent. So They could be implementing some energy to maximize their the resource, right, for their renewable energies. And with these renewable energies, aside from their plant, then they could actually perform better energy management. And then from consumer to prosumer, so this is something that we had today. Actually, we are starting to have today. So when we say consumer to prosumer, is that aside from you being a consumer of an electrical load, there would be a chance for you to actually sell your own electrical load. All right. So this will be something that we need to do. But imagine of all of this stuff. All right. So you will need to have a very smart components and a very like a future ready components for this, because if your component is not that smart, then it would be impossible for you to control these energies that you have in your facilities. Okay, so this is actually the overview of the complexity of what will be in our in the future. All right, so from your home, right, from your home, and then for the electric vehicle that will be coming in for the future. So the electrical vehicle can actually do the vehicle to grid concept. Okay, so what does it mean? So any energy store in the electrical vehicle can also be sold to the grid. So this is what the vehicle to grid concept. And then control in-home appliances. So basically this is the BMS system that we had. So technically what we're seeing, everything in here is what is happening. But the policy, the regulatory, the things that has to be done is still on process. All right. So, but the trend, we are actually experiencing the new trends that we had. All right. So as we go further in our future, this will continually to improve. This will continue to improve, and this will be more complex, but we can control it through digital. All right. So this is why we need to be. What this is why the digital future is coming. Okay. So with this one, okay. So our solution for our digital solution is our ABB Ability platform. Okay. With the ABB Ability platform, it is highly scalable, user friendly, and it's an open platform. Okay. So when you say an open platform, the platform itself is free. Okay. So what do you mean? What do we mean by that? Okay. So what we mean is that if you are a third party software provider and you wanted to, if you have some ideas to improve energy efficiencies, so you can actually use this platform and integrate your software solution to this platform, wherein the ABB components can actually use. Okay, so this is why it's an open platform. And also, we are in partnership with Microsoft Azure as our cloud provider. And with the quick updates and upgrades, so everything that happens on the system, you can actually access it right away. So if there would be a new update, then your system will actually benefit on this one. All right. So we also use this software as a service. All right. So when we do this software as a service, then what we do is that since the platform itself is free, but the services are per subscription basis. Okay. So this subscription, why we need this subscription basis? Because ABB algorithm is also embedded in this system. So with the ABB algorithm that is embedded in the system, this can actually help you improve, predict, and even control the energy consumption that you will have, and also forecast energy cost and energy consumer in, let's say, in the next 3 days. Okay, and this one is This one is have an artificial intelligence in it, wherein the best or the most accurate possible forecast will be given. So the more data the plant will have, the more specific and the more accurate these things will perform. Okay, so pay what you need. So with this platform, you only need to pay what you need. It's not that you pay everything, but in a certain price, and then you don't need this. So you have the capability to customize what you need, and only pay for anything that the facility is required. Okay, and don't don't worry, because the price of this one, you can actually use the ABB marketplace to check the price, and you will be amazed at the price. So this is actually something that very very let's say cost efficient. And anything that you do with this ABB ability platform, and any subscription that you made, then we can actually see the ROI within a certain amount of time, or if it's not a year, or within the year. So this is something that will benefit you. And then an on-air support and maintenance. So everything will be on the cloud premise. So if you have any problem, you can connect with us. You can actually send us an email, and then we can know what would be the problem. So this depends on the subscription that you have. All right. Okay. So with this one, with the ABB ability that we have, or the ABB ability platform, we have the so-called the EBCS, which is the cloud-based monitoring system. Okay. So with this cloud-based monitoring system, so if you have this local system that you have here, right? The parameters or the data that are in this system can actually be transferred to the cloud. And from that cloud, those data were used to give you some analysis on how can you have a better energy performance. Okay, so with this ABB Ability EBCS Cloud system, the system is actually a plug and play solution. All right, so a plug and play solution wherein there is not need of too much integration. So everything is there. And then the remote supervision of facilities. So if you have multiple facilities, let's say you have a plant 1, plant 2, plant 3, up to plant N, you can actually monitor all of your plant in just a single device. So this can be done with the EBCS. And then the images, the tags, the markers, you can actually use those things as the parameter. You can see the parameter, what's happening on your air circuit breaker, what's happening in the meter, what's happening on the MCCB. So all of this will be provided in the EBCS platform. Okay, so and the measurement that is available will depend on the component that is installed on site. So the ability to perform and even measure harmonics. So this is dependent on the components that was installed inside. All right. And the data storage, regardless of how many the data that you have, it is unlimited, and depending on the subscription that you have, we can have the data stored for you up to 2 years. And if you have this extended data storage, then we can have those data storage up to 5 years. All right. So what happened is that, example, if you have only purchased these 2 years, the standard one. So what will happen is that we will give you, example, if it becomes 2 years, then we will give you your data. Then you can save those data later on. And then if you needed those data, then you can also put it back on the cloud. So something like that. So this is a very, very flexible solution, and very intuitive, wherein it's not that hard to understand, but it is also easy to control. Okay, easy to manage. All right. So some sample of those energy management that we have is like this. All right. So we can actually see the power quality. All right. Then you can actually check the devices that you wanted to check, and then the parameters that you wanted to know, and then the power demand that you have experiencing real time, and then the contractual power that you have, right? So these are actually a can be a user specific data, and the active power. Then this one is the real time power consumption that that the facility is experiencing. Okay, and with the energy monitoring, okay, so you will see the on-site generation on grid. So you can actually see how much you are using on the grid and how much you are using in your renewable energy or even with your generator. So everything will be monitored. Okay. So this is the since we have this cloud monitoring. Okay. So for example, we have this demo. This is actually a demo from Singapore. All right. So if there are multiple, if your plant is in multiple sites, example for Philippines, then you will be able to see a like this pin on Singapore and then on the Philippines or any place in the world. And then you will see all those factories or all those facilities in this area. Okay, so with this one, this is actually a highly integratable system wherein we can use API. If you have those local EMS already and you wanted to get those information from the ABB Ability EBCS, then we can actually share those information from EBCS to your local SCADA through the API. Okay, so complete electrical asset monitoring regardless of the application, right? So what we do mean with this one is that whether you use your laptop, your desktop, or your mobile device, you can actually see the same thing on all those platforms. Okay, so this is something that is can be monitored by you or by your staff. All right, so this can give you actually an overall 360 view of your plant. Okay, so all right, so why digital? So how can you fix a product if you don't know what is broken in it? And how can you improve if you do not know where to improve? So this is our statement with this digital transformation that we had. Okay, so this is the more information that we have, then the more we will be, the more that we can be resilient on things that can happen on our facility. All right. So on top of that, we have in the ABB Ability EBCS, we have this preventive maintenance. All right. So this preventive maintenance can actually help you save a lot of costs, especially when you do the preventive maintenance costing or your annual budget, because you will see in here, this is just an example of the preventive maintenance. So what we call here is like a stoplight codes. So if it's in green, so it means that the breaker is actually performing in the most reliable way. When it goes to yellow, then it says that you need to maintain it. And when it goes down to red, then it means that you need to replace the breaker. All right. So if you wanted to know when you can replace the breaker, then this is something that you can actually use as a data. And you can see here from 2015 to 2040, we have made some studies that with this performance, okay, so with this performance, you can actually extend the lifespan of your breaker for an additional of 10 years. All right, additional 10 years. With this one, it's not only gonna save you money when it comes to OPEX, but it's also gonna save you money in terms of CAPEX. All right. So because you will be able to know when and budget when you need to replace those components. Okay. So with the EDCS, actually it is energy audit ready with the ISO 5001. So with this widget, all right. So this is applicable to EDCS. So you can add this widget to your EDCS subscription, and then if you wanted to check and improve, so when you are by ISO 50001, what we're saying is that it can actually provide you savings up to 30%. All right. So this is actually the ABB Ability ADCS solution that we had. All right. So the ABB Ability ADCS solution cannot perform as it is, how great it is without the common components. All right. So what are those common components? This is our standard solution. All right. So these are the solutions that are actually embedded in the system. So in this system, what we are seeing here is the EKIP trip unit. All right. So for the EKIP trip unit, you can see that there is this monitor here. All right. So these are actually touch screen monitor with this one. Okay. So some of the screen are with the small range. With this one, you can have the button because this is too small already to be attached to. So with this EKIP chip technology, what we are showing to you is actually the technology is embedded to our MCCBs and to the EKIP app. All right. So previously, in past last year or even 3 months ago, we were yet to develop the technology to the MCCBs. But now we are actually whatever technology that our ACB had can actually be incorporated with the MCCBs. Okay. So what does it mean? With this technology that we had, okay, so if you wanted to measure those data, like whatever happens in your system, you wanted to know and you wanted to drill down what is the cost of those power interaction, let's say. So what you need is to have an accurate measurement. All right. So accuracy is also a key. With these breakers, they are actually certified class 1 in accordance with the IEC 61557-12. Okay. And the accuracy of 0.5% when it comes to current and voltage measurement. Okay. So when you say accuracy of class 1, this is actually a good parameter, or it's already a good accuracy for you to get a feel of what is the real data that happened in your electrical facility. Okay, so if there would be some power interaction, then the data that will be provided to you, you will be confident that those were accurate. Okay. All right. So aside from this one, since there is a lot of technology being embedded in here, all right, so we will discuss little by little those embedded technology on this EKIP trip unit. Okay, so with this technology, we also have this EKIP signaling treaty. Okay, so with the EKIP signaling treaty, this is an accessories that you can put into the ACB, and then you will be able to measure the temperature that is happening on the bus bar, on the transformer, or in the switchboard. Okay, so this environmental condition with this EKIP treaty, this can actually make the predictive maintenance more accurate. Okay, So since it will be able to gather data, the actual temperature or the actual environment condition when it goes or when it analyze its predictive maintenance, all right, or the longevity of the use of the breaker. Okay, so with this one, um, most of the time there are some facilities that require to check the temperature of the switchgear. So with this one, by putting this one, you can actually create or have those information given to the trip unit monitor or through the cloud or EDCS. So if you are connected with EDCS with with these accessories, then you will be alarmed. It can give you an alarm whether you reach a certain amount of centigrade or temperature, then you will know what to do on the plant. Okay, so this can actually give you control on your plant. Okay. Also, so it's the ease to analyze the power quality. Okay, so with the eKeep High Touch or the touch tip unit with the measuring pro accessories, then we will be able to measure different kinds of energy. All right. So with those measurement with energies, then there are two types. Okay. So there is this measuring and then measuring pro. So when you have this eKeep measuring installed in your eKeep chip unit, then you will be able to measure this uh, energy data. But with eKeep measuring pro, then you will be able to control the breaker or to set the breaker to trip at a certain level of energy that you wanted to control. So what does it mean? It means that those data that are let's say important, or if it's the example for the harmonics, if it's important for you to trip at this level, then the breaker will trip. So this you can have the complete control of your energy system. All right. So with the eKeep trip unit technology, it's not only the trip unit but the plug solution, wherein it can also have different kinds of communication. Okay. So with this communication that is available to us right here, you can also convert those communication from example from Modbus TCP or Modbus RTU to Ethernet IP or vice versa, or depending on the system depending on the system that you had in the facility. So this is something that is very unique with this system. Okay, and all of this stuff can be commissioned with the eKeep Connect tree. Okay, so with the eKeep Connect tree, you can commission all the parameters using your laptop, and then with the Epic commissioning tool, wherein you can download through to the Play Store and App Store, are actually available. So with the new product that we had, the Bluetooth is actually embedded on the MCCBs and also with the ACB with the black trip unit. Okay, so as of now there are two types. One is the gray and the other one is the black. So with the black trip unit, it has an embedded Bluetooth in it. Okay, so with the light panel is like an HMI on an electrical system. If you don't want to control the breaker on site, like per column, so you can actually use the light panel to control all of those components. Okay, and they can be integrated with those eKeep communication module that we have here. All right. Okay, so with this one, so we go to the MCCBs, or what we call the new range. All right. So with this TMAX XT, all of those technology that we had from the previous slides are actually embedded to these MCCBs. All right. So you can see here, there is the segregation. All right. So you have this XT2, XT4, XT5, XT7, and then in between there is XT6, XT3, and XT1. So what are these segregation for? All right. So technically, with this one, the MCCB or the trip unit that are present to them, okay, are this one. So with the Thermomag trip unit is available from XT1 to XT7. The eKeep Deep is available to XT2, XT4, XT5, XT6, and XT7, but the eKeep Touch and High Touch is actually available to XT2, XT4, XT5, and XT7. So what does it mean? It means that we have some we have a component that can be digitalized, and we have component that can be used on the standard function. And what you can see here with the eKeep Touch Tip unit, you will have a lot of protection advantage. Okay, so with this one, and with the help of the digital technology, these are actually upgradable into a better chip unit, right? So we will discuss it later, further in this slide. Okay, so we have here, so for the architecture, okay, so in this area we have the electromechanical performance, or what we have is that we wanted to the higher KA rating, and then this one is the feature of the breaker. So from the traditional concept to the smart concept, okay. So you have this breaking part that could have this traditional concept, okay, and then into the smarter concept. So with the touch tip unit, all right. So with this one example, if you wanted to have a further advanced protection, then these two circuit breakers that we had here can be upgraded into a new features, or with advanced protection that we can download to the ABB Ability Marketplace. Okay, so when you can check this ABB Ability Marketplace. You can use Google and check the ABB Ability Marketplace and see what's inside. Okay, so when you see what's inside, you will actually see how much is those upgrades that I am talking about. So, and you will be surprised. Those were actually very, very cost efficient. Okay, so with this one, with the traditional features, so we will gonna use for traditional application. Then we have the XT1, XT3, and XT6. Okay, for distribution, motor, and generator. And then for the standard and advanced features, then we have this range. Okay, so previously, what ABB is offering is up to XT4, but now we are offering up to XT7. All right. So with this one, with this offering, what you will have is the standard protection, advanced protection, connectivity, metering, and embedded logics. Okay. So for the standard protection, if you buy, example, the eKeep Touch, then you will have the standard protection and monitoring. But then, if you buy the High Touch, then you will be able to have the standard protection, advanced protection, and and also the meter. The connectivity and the embedded logics is something that can be upgraded or customized later on. Okay. So with this one, the plant management, if you have those kinds of breakers embedded into your plant, and then it is the breaker is smart enough to communicate through cloud, then you will be able to monitor. No, you will be able to monitor what is happening on your facility or in a specific place or on a specific motor. Okay, so if the specific motor is experiencing overload and you need to put up another motor, then you will be able to sense those and manage this problem. So once you will be able to sense, manage, and act, then the uptime or the uptime of your facility being undisrupted with these kinds of failures, then it will generate more profit from you. Okay, and the integration will be very fast since it is it is a native to we can choose any communication that is native to the plant. Okay. All right. So this is the touch and high touch. This is what I'm talking about. So this is actually intelligent trip unit from 160 amps to 1,600 amps. Okay. So this is for the MCCB. But what we are looking at, if we put in the ACBs that we had, then the range is actually from 160 ampere to 6,300 ampere. Okay, because they are sharing the same technology. So what is the technology from the ACB on the previous slide is also capable of doing, the MCCB is also capable of doing those things. All right. Okay. So when it comes to metering, so in terms of metering, then you will be able to measure this current, voltage, phase sequence, frequency, power factor, peak factor. Okay. So these are for the touch tip unit. You will be able to measure up to this one, the standard one. But if you have the high touch, then you will be able to measure everything in here. And then all of those breakers, measurement of those breakers were actually a class 1. Right? So it's class 1 ACB, class 1 also MCCBs. All right. And then the availability of the data is instantaneous, or we can have the historical measurement. So actually, it depends on the fidelity that you wanted to measure. When you use when you have the high touch, it has an embedded data that it can record. So it's up to you whether you wanted to use every 5 minutes or 10 minutes loop, but this one will be measuring every time, every 5 minutes, whatever the measurement there, it will be recorded. So first in, first out. Okay. What I know is that there is like a 24 points that you can actually use. So example, if you have those points that measured every hour, then you have data that is good for 1 day. So this is the data. Okay. And for the communication and connectivity, all right. So with the communication, local connection could be in the embedded Bluetooth technology, and the equip multimeter and the control panel connectivity. So if you have those on its panel, the touch panel, so you can have those local connection. And then for remote connection, so those were the 10 communication protocols, like the equip com hub, equip com modbus, equip com IEC 61850, so something like this. And then the cloud connectivity. So you have the exploit the full service of the ABB ability. All right. So connection with the new breaker is easier. Okay. So with this one, this is the one that I'm talking about. So if example you bought a function, or you bought this equip touch, for example, and then what you say, oh no, I need to have this measurement, the voltage, power, energy measurement, and voltage and energy protection. I need those. So if you need those, then it can be easily upgraded through the marketplace. Okay. So what if equip touch and equip high touch need the network analyzer, data logger, and the functions and logics? So function and logics that we are talking about here are the embedded technology. So with those functions and logic, so actually those were licenses that can be extended and can be bought into our marketplace. Okay. So with this one, so what are those things that software function that we're looking at? We're actually looking at the software function of interface protection. Okay. So the interface protection can be done by the ACB and the MCCB. Load shedding. capability. So it can be done by both ACB and MCCB, the ATS, the synchro reclosing, and the power controller. So, by the way, guys, example for the power controller, we will have to have an additional function in terms of our hardwares. Okay, and then for the protection measurement, these are an added protection. So usually our best trip unit is the EKIP G trip unit. So it is the most advanced. So for the high touch, so it lacks the advanced voltage protection and the generator protection. Okay. Okay. So that ends up with our MCCBs and our ACB, and now we do go to EKIP Up. So EKIP Up is our solution for those systems that are let's say there is an old low voltage switch here, and then you wanted to upgrade it. Then this is the best solution that we can offer. Okay, so with this one, the EKIP Up is available from 1,000 amperes to 4,000 ampere of operating current range. So we do some retrofit, and we put the EKIP Up on the working breaker, but the trip logic of that working breaker will be transferred to this EKIP Up. All right, and then for the current sensors, we have type A, type B, and type C. So for those function of the EKIP system, right? So we have the case of for the monitoring function. Okay, for the monitoring function, let's say we have an ABB old circuit breaker here. So since it doesn't have the embedded technology, or it doesn't have the EKIP chip unit technology, so what we're going to do is that we're going to put this EKIP Up on the system, and then we will use this breaker as the mechanical function, but the trip unit will be this one. So when you put the EKIP Up, it is actually the same trip unit of the EMAX2, only taken out, and then it has the slot to plug in those EKIP COM modules. Okay. So in order to have this installation, then you will have the EKIP Up monitor, the EKIP Type C current sensor, which is the Rogowski coil, and then the EKIP supply module. Okay, and then the rating installed rating plug. So the rating plug is actually dependent on the system. All right. And the EKIP programming and EKIP Connect. So these are actually, the EKIP Connect is free. You can download this one. You can use Google. But the EKIP programming is this part here. So the EKIP programming function is the one that can communicate to the ACBs, MCCBs, and also for the EKIP Up. Okay. So, but example, if you don't have this and you have the EKIP let's say EKIP Ethernet IP, then you can just use the RJ45. Then it's the same. You can communicate with those breakers. So imagine if you have those breakers connected through LAN, and then you wanted to monitor. Let's say 60 breakers are connected in LAN, and then what you will need to have is one RJ45 cable and connect on the same network. Then you will be able to monitor all of those 60 breakers right away, and you will be able to monitor them real time. Those data on those breakers, you can get those data. Okay, so this one, this is used also for meter monitoring. Okay, so because since we have the EKIP 3T signaling, so we can use it as a sensor. and have those analog signals also to the monitor. And then we can, all of those data, if we have those, if we have those, let's say ADCS, then we can transfer this data to BMS or to the ADCS. But for example, for this analog signal, so whatever analog signals that we use here, so this could be a 4 to 20, let's say 4 to 20, and then, or let's just say we connected it to a pulse, and those data can be transferred or converted into the EKIPCOM protocols that you will use on site. So this is something that is very interesting. Okay, so this is what the other thing that we can do is that we can also integrate it with the SCADA server. So the SCADA server, it could be an IEC 61850 because we have those protocols. Okay, we can do the communication. So if the SCADA server is IEC 61850, or either then it's a Modbus TCP IP or a Modbus RTU, then our EKIP app is actually capable on sending the information that we have for the circuit breaker to the BMS. Okay, and then this one is aside from the BMS, we also have the cloud platform. Okay, so as you can see, the flexibility of the EKIP technology that we had, so we can do the retrofit from the old system to this new one. All right, so there is actually 3 EKIP apps. So you have the one is the monitor that we have here, monitor, then protect, and then control. Okay, so with the protect function, so this can actually you will be able to have the guarantee of the short circuit breaking capacity equal to its withstand current. So it can send a signal to the breaker so that it will close down aside from the monitoring. Okay, so but with this one, there is the current sensor that is connected to the EKIP. Okay, next is with the use of the class C or the Rogowski coil. So it's the same situation. So with the Rogowski coil, then we will be able to we don't need to have some changes on the bus bar. So we just need to wrap the Rogowski coil around the bus bar. Okay, and with this one, same for the EKIP up. Then for the I/O, anything that is if the EKIP up sends something that is beyond its parameter, then it will send a signal to the breaker. Okay, so in case that there is a spare trip units, okay, so retrofit any electronics of circuit breaker, postpone investment to device replacement. So these are the things that our solution that can provide you with your existing switchboards. Okay, and then this is more of a complex scenario. So this one is the interface protection system with the for the connection of renewable or co-generator or the generator itself. Then what will happen is that we will have to monitor the side of the utility and also from the low voltage side. And then from those embedded logics, okay, so we will know whether we need to trip the breaker or not. Okay, so the EKIP synchro check here is actually checking the synchronization of the voltage and the phase current. So this would be a function wherein for the interface protection, okay, for the interface protection unit for the medium voltage to low voltage system. Okay, so just like the IPS embedded IPS system that is in the MCCBs and the ACBs. Okay, so there are more of this stuff that we can do. So synchronism or synchronization, and then the load shedding. Okay, so all of this technology with the EKIP up or EKIP technology that we had for the breakers are actually applicable even for the renewable one or for the old system, I mean. Okay, so logics. So these are the logics that we had, and the directional protection, and then the adaptive protection. Okay, so with this one, you can check all of this protection. We can have those, if you are interested with these kinds of protection, please do let us know, as we will be tackling only the overview. All right, so this one is the control. Okay, so with the control system, the EKIP up control, so it's used for the peak shaving and load shifting capability. All right, so with the embedded algorithm that we will put in the EKIP up. So since there are three, the EKIP monitors, it's only monitor. The EKIP protect, it protects. Then the EKIP control, then it controls the breaker. So with the EKIP up controller. Okay. So this is just a one system. So for the demand response, okay. So what we have here is the for the load aggregators. Okay, so with the embedded algorithm of the system, or we can we can actually, the EKIP app control can actually get those data, and then those data will be can be controlled, can be transferred to control the load. Okay, so with this one, we have these components that are required aside from the chip unit. So the EKIP app control and the current sensor, these are also, this four is always a must, but on how you can customize on how you wanted to use those systems is up to you. It's up to you guys. So if you have those kinds of requirements, please let us know, and then we will discuss this to you in a very detailed way. All right. And this is the standard supply. So when you say EKIP up, so it's just a standard supply. You have the this one, this component, and then you have the modules, maximum of 5 modules. But those 5 modules were actually those were customizable, shall we say. So whatever modules that you need to let us know. All right. Okay. So for the greenfield application of the EKIP trip unit, then we can use those circuit breakers. Okay, aside from those systems, then we can use those the breakers that we had and the components that we had for the substation. Then we can put them all together in the cloud in just one EKIP system. Okay, and then for the brownfield, so what we do for the old breakers, we have the EKIP up, and we can use the PDM or power monitoring device that we have here. Okay, that we have here. Then those information can go through the cloud as well. Okay, and then the control consumption of load. So this is the EKIP power controller, wherein we can use for the EKIP device of EKIP EMAX2. Then it can give us a reduction of energy cost of up to 20%. And then for the power absorption, so for the EKIP smart power controller, so less than 20%. So this is the you can see a small diagram, an overview diagram. So with this, we have this energy saving. So from the payback time, if you install those load shedding, example, this load shedding, this is actually an accessories. So this is not a subscription. So this is an accessories. So with those load shedding, then you will have those payback time into these years. Okay. All right. So some success stories that we have is from the Burj Khalifa. So from Burj Khalifa, what's there is that they have a 400 electrical loads, 57 elevators, 24 megawatts of ACU, and what they require is that they wanted to reduce the OPEX, and then they wanted to have the real-time monitoring. And since the electrical facility there is already old, so they wanted a plug-and-play solution that they can adapt easily. So our solution is to use the eKeep app and the ABB Ability EBCS eKeep app to update those old hardware, and then the ABB Ability EBCS for the software for monitoring of those lines. And then the output is that from the installation, they were able to reduce up to 30% of their operational expense, and then they were able to monitor all of those components that they wanted to monitor, those critical components that they wanted to monitor. All right, so with this is the overview of our ACB with the eKeep technology that we have and the protocols that are available in it. Okay, so as you can see, the accuracy level in here. So this is for the high precision. If you require a high precision one, then let us know. Then we can provide these kinds of accuracy. But for the standard one, we have this one. Okay. And then for the MCCBs, it's almost the same as our ACB. And then the system itself. Okay, so we have 3 inputs, PP 100 for temperature monitor, and 1 channel for 4 to 20 milliampere input. And then this is the eKeep app for our retrofit solution. And aside for this one, so what we're showing you is that with the True One ATS that is also included, because the True One ATS, the eKeep app, the ACB, and the True One ATS is actually the gateway to our EBCS system. Okay, so with this one, we will share you our presentation, and you will be able to see those references with this link. And then thank you so much for your attention, and let's hope to see you in for the next webinar. Ms. Barbs, giving back to you the floor. Thank you.
Okay, thank you, A. So please don't put down your slide first. We'd like our audience to take note your specific details. No, so as you can see, A has shared with you his email address and mobile number, as well as his LinkedIn platform. So should you have any requests for product information, just don't hesitate to reach out to him. And while we allow him some seconds to take some air, he has an extensive presentation. Again, we'd like to share with you and again invite everyone to our upcoming upcoming DC Summit. So if I may just share this content with you. Let me just give the full scroll.
Okay.
Okay. Thank you. So, again, we're flashing here the details for our ICBC Summit. Direct Current, Your Next Energy. This is going to be on November 24 and 25. I have shared the website for further links and details and information. And also, I have also shared here with you the registration link, which will immediately take you to the live registration platform so that you can secure your slot for this. So absolutely, this is for free. And all you have to do is register to our website. So I will be posting it again in a few minutes after we have entertained some questions from your end. So Ace, let's get right to it. There's a question on Um, what does class 1 accuracy mean?
All right. Okay. So class one accuracy means is actually there is a plus minus percent difference with the actual number. So example, if the real time number, let's say the real time data is 100, then there might be the facility or the component will be able to measure in between of 99 to 101. So it is somewhere between the measurement is will not go outside with that range. So it means that the lower the accuracy, so the finer it gets. So with the class one, when you say class one, 1%, so that is actually the plus minus of the data. Okay.
Oh, sorry, go
Yeah,
ahead, Ace.
I think our colleague Joe Mayo can actually add more on that.
Well, actually, it's pretty much the same explanation. It varies depending on the standard and depending on the equipment. So yeah, as Ace explained earlier, it's the difference in it's basically the range, the plus minus range from the real reading, supposedly the ideal reading of the equipment or the measuring equipment. Yeah.
All right.
Okay. Ace, you've mentioned an actual case study, no, the Burj Khalifa. How about for the Philippine setting? Do we have one that we can share with the rest of the audience?
All right. So when it comes to installation of our Emax 2, then we have multiple installation of Emax 2s here in the Philippines. But I'm not so sure if we can disclose this, but for the local installation of our EDCS, okay, so we have one in our office. So this would be online, I think by this month. Okay, so but we are actually promoting this EDCS system. For those who are interested, please let us know, and then we are actually giving a free demo of this EDCS system. So if you have those, if you wanted to experience what is EDCS, then let us give us a chance to put on a demo on your plant.
Okay. Okay, thank you so much for that, Ace. I just recalled, Ace, that we have this free subscription for ABB Ability.
Yes, the free subscription for ABB Ability. This is actually a software as a service. So since this is a software service, then there is a free subscription for 1 year. All right. So any one of you that are interested for this one, we are giving the free subscription is available until December 31 of this year.
Okay, I believe we have a clip for that. Please let me share it with the rest of the team and with the rest of the audience. So if you could just give me a few seconds to share this file. Okay. So this is
yeah. Yes. So
okay.
that is the free subscription. So the good thing about this one is that the devices are up to 90 devices. Those were free. So any subscription that you have, whether you have, let's say, 3 times subscription, as long as it's a subscription, then it's free. until the end of 2020.
Okay. So I think that's all we have for you this afternoon. So there are no more questions from our audience. So at this point, I'd like to wrap up our webinar session. Thank you, Ace, for that extensive presentation that you have prepared. Thank you to our panelists. Thank you, team, and to our audience for spending their time with us in this episode of the live webinar session for ABB electrification. So on behalf of ABB Philippines and ABB webinar team, maraming salamat po. Thank you so much for joining us. We hope to see you in our next sessions. Please continue to keep safe, everyone. Maraming salamat po. Thank you.
Thank you. Bye-bye.